Hello everyone, welcome to the next tutorial. In this tutorial, we are going to find the equivalent capacitance of various electrical network. Okay, so the first electrical network over here is given like this, and we need to find the equivalent capacitance between the terminals A and B. Okay, so as you can see, these two capacitances are connected in parallel. It means that the total capacitance of these two combination will be equal to, so it will be equal to CT will be equal to C plus C, which will be equal to 2C. Okay. Similarly, in this case also, these two capacitances are connected in parallel. It means that they can also be added directly. So the total capacitance of these combinations will also be equal to C plus C, which is equal to your 2C. Okay. So after simplifying, we are getting this type of electrical network. Okay. So this will be your 2C, this will also be 2C, and this is your C. And we need to find now the equivalent capacitance between the terminals A and B. Okay. So as you can see, these three capacitances are connected in series. It means that the equivalent capacitance 1 by C equivalent will be equal to 1 upon 2C plus 1 upon C plus 1 upon 2C. Okay. So that is coming out to be your 2C 1 plus 2 plus 1. Okay, so it means that the value of the C equivalent, the equivalent capacitance between the terminals A and B will be equal to 2C upon 4, which is equal to C by 2. Okay, so I hope it is clear. Now let's start with the second problem. So in this problem also, we need to find the equivalent capacitance between the terminals A and your B. Okay, so in this figure, as you can see that this node and this node both are same because they are connected via same branch. Okay, so it means that the simplified version of this network will be, so it will be like, so it means that we can short circuit these three capacitors. Okay, so this will be the simplified version of this particular electrical network. Okay, so as you can see, these two capacitors, okay, these two capacitors are connected in series. It means that the total capacitance or the equivalent capacitance of these two capacitors will be 1 by C equivalent will be 1 by C plus 1 by C. So C equivalent will be equal to C by 2. And their series combination is connected in parallel with this particular capacitor. So we can say that the total capacitance will be of these three capacitors will be, so C total will be equal to C by 2 plus C, that is coming out to be your 3C by 2. Okay. It means that, so we can re-simplify this particular electrical network like this. Okay. So as you can see, these all 5 capacitors are connected in series with each other. It means that, so it means that the equivalent capacitance 1 by C equivalent will be equal to 1 upon C plus 1 by C plus 1 by C plus 2, 3C plus 1 by C. So we are like, it is coming out to be your 4C plus 2 on 3C, which is your so it is coming out to be 14 upon 3C. So the equivalent capacitance of these capacitors of this electrical network will be C equivalent is equal to 3C upon 14. So I hope it is clear how we are approaching this problem. Okay. So let's start with the third problem. Okay. So in this problem also, we need to find the equivalent capacitance of this network. Okay. So as you can see, this node and this node are both same. Let's say this node is your C, okay, and this node is your D. So as you can see, the 2 microfarad capacitor and 4 microfarad capacitor are both connected between the same nodes. It means that they are connected in, so they have a, you can say they have a parallel connection. Okay, so they have a parallel connection. So it means that, so it means that the total capacitance of these two capacitors will be equal to, so C total will be 2 plus 4, which is your 6 microfarad. Okay, so we can re-simplify this particular network as, so this will be the simplified version of this electrical network. Okay, so as you can see, these two capacitors, 6 microfarad and 3 microfarad capacitors, are both connected in series. It means that the equivalent capacitance will be, so the equivalent capacitance C equivalent will be equal to 6 in series with 3, which is your 6 into 3 over 6 plus 3, which is coming out to be your 2 microfarad. And this 2 microfarad is in parallel with this 2 microfarad capacitor. So the net C equivalent capacitance between the terminals A and B can be given as 2 plus 2, which is equal to 4 microfarad. Okay, so I hope it is clear how we are approaching this particular problem. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.